Before we go through the content, let me introduce myself a little bit. My name is Lennon Chu. I'm a Taiwanese based in Taiwan. I am the Fortii PPA Material Market Development Manager and joined with the DSM Engineering Plastic staff from 2010. I've been in various roles like the application development and engineers for the technical developments and also for the business development managers as the commercial activity covering. The focus industrial will be increasing the automotive, electronics, and also the electronics. Look at the existing charging voltages for the battery charging. The majorities, including like the car model Tesla, the charging voltage will be in range start from the 300 volt to the 400 volt. And for the future market developments, which already announced to the market, including the Aston Martin Rapid E, Porsche Taycan, the battery charging voltage will be increased up to 800 volt or even higher, which means the charging voltage would be significant increase at least the 1 times. And one of the key benefits to increasing the charging voltage in batteries, and that would be get the biggest benefit to shorten the charging times. The outcome can provide the most convenient user experience to shorten the charging time and not to waiting for the long periods for your battery chargings. Ideally, this can help in the electrical vehicle to get the more market shares. If you look at the comparisons chart in here, you can briefly understand. For example, if you have the output power start from the 100 kilowatt with the charging voltage start from the 400 volt, then you get the charging time around the 40 minutes, which including the different model like the plug or the battery cells. To further increasing the output power to the 220 kilowatt and also increasing the charging voltage to the 800 volt, then ideally the charging time will reduce to the 90 minutes only. So that means at least 50% the reduction of the charging times. And that provide there's more room for the users to choose the car instead of only choosing the traditional internal combustion engine. Then the EV will really become the good options for the futures. Besides of the highest charging voltage in high voltage systems, another change happen in the high voltage component. There would be the miniatures and also the increasement of the packaging densities. We're using the example in here. You can see the IGBT modules, downsize of the geometries for the individual components. And if you get the downsize of the electrical components, but considering, as mentioned in before, the increasing the charging voltages, so that means the safety of the electrical performance would be more relevant and critical. Another examples in here for the inverters to install with the several IGBT modules. You can look at the example in here. Start from the one inverter bracket to carry the 6 IGBT module, and by increasing the packaging densities to increasing the efficiency of the output powers, and then the most the challenge would be the reduction of the pitch. Start from the 6 carriers with the IGBT modules and increasing to the 10 IGBT modules, the pitch can be reduced up to the 35%, So there's really the big difference on the creeping distance. We already explained the future change for the high voltage system, including the higher charging voltage and miniatures. But don't forget about it. The biggest concern for the electrical safety, there will be the check-in risk. For all the engineers, always try minimize the check-in risk to get a zero incidents. If you want to minimize the check-in risk, you always need to consider the 3 key factors. The first one would be the creeping distance. Based on the definitions, you can clearly understand the pitch size and minimal wall thickness of the insulator plastic are clearly defined and cannot be changed. But we already mentioned, since the miniatures bring in the challenge in the shorter the creeping distance, so the insulator materials will play the even more important roles. And the second factors, there will be the environmental pollutions. Of course, right now, the technology improved on the ceilings already provide a good solution on this one. So the environmental pollution levels, you always can minimize it to avoid any dust, contamination, penetrations by using the ceiling technology. To anchor in the creeping distance getting the shorter, the higher CTI insulation material would be very important. The higher CTI material like the PLC zeros or the CTI range as the 600 volt and above, they will be very important as the essential elements. But if you look at before, standard CTI material, the classifications, the only can be qualified for the 600 volt. Above the 600 volt, there will be the necessary future development and require the material studies to provide a specific CTI rating to above the 600 volt. The reason was want to make sure the electrical safety by the market trend of the highest charging voltage and the trend of the miniatures of the high voltage components. Based on these reasons, DSM Engineering Plastic as the material suppliers, we provide the solutions including the PPA material for T. We already proceed the testing to specify the CTI above the 600 volt. We've been cooperating with the third parties, including like Eltec in Euros, and using the DSM material, like the Fortii material TS1s, get the CTI ratings above 600 volt with the maximum results like the 900 volt. That's the significant results compared to the standard CTI classifications, and they also provide the designer a guidance or clue for the future design in the miniatures of the high voltage system or the highest charging voltage systems. Besides of the PPA material, we also test the standard PA66, including the DSM Acculon PA66. This material also is the V0 halogen-free material, similar like the Fortii, but the best polymer was the PA66. And the outcome also is very good. The CTI get the rating is a 700 volt. But in here, you can see the clear difference between the high performance polyamide material like the DSM-40, the CTI would be higher than the PA66 like the Acculon. And as we know, the PA66 material were commonly to use in the high voltage connectors. So in case for the futures, if the high voltage connectors need to change in the miniatures designs with the higher the driving currents or the forward voltage, then you can consider in the high performance polyamide like the Fortii. We've been emphasizing the importance of the CTIs, but in here we would like to bring you a simple equation to have more clear understanding why the CTI is important. And they can really benefit for your electrical safeties. By these simple equations, we're using the assumptions, which means that we assume the energy to create the arc in the two different materials will be the same. And also to put in the time as a constant. And then you can roughly to understand by the difference, the CTI material, like the DSM-40 CTI 900 volt, and compare to the low CTI material, like a standard PPAs with the 250 volt, and the creping distance, there will be really the big difference, almost like the 7 times the difference. So that means that for the future designs, especially in the miniatures, you get the shorter creping distance, then the higher CTI always can helping you to ensure the electrical safeties. Besides of the polyamide material, we also summarize the table in here to put in the different base polymer, including the PPA material and the polyester material, and also the PPAs materials. And you can see the standard PPAs material, you always get a lower the CTI ratings. But more important is the, in case of for the future development in the higher charging voltages, to specify the CTI above 600 volt is already the very important one of topic to study. And the DSM right now, we already can provide you the data for your reference in your future designs. Besides of the CTIs, for a standard electrical performance, considering electrical safeties, they will be including like the volume resistance and also the dielectrical strength. But we would like to highlight in here for the volume resistance, especially to focus on after conditioning, which means the absorb more moistures after the conditioning. Some of the material like the PS60, which including the PA66 polymers, they're probably facing the issues is the uptake too much the moisture and leading the volume resistivities to drop down. For the second topic, we will share more details on the ECUs and the mechanical performance in terms of the ECU development. Some of the people will say the ECU electric control units will be like the brand of the cars. The ECU play lots of the different roles in the different applications, including the powertrain, telematic, chassis body, and even the high-end application like autonomous driving. And one of the problems would be by the different applications, you got lots of the amount on the ECU. We put in the table in here, you can understand just only the 5 different applications start from the powertrain until the autonomous driving. The amount of the ECU can up to the 200 set. So by the chipset company like the Intel to provide the high efficiency chipsets and optimize the performance, then you can have the more functionality integration further to consolidate the amount of the ECUs. And bring the challenge for the ECU not only to reduce the amount, and potentially also to reducing the size of the ECU, especially for the PCB. So to reduce the PCB amount and the size, they also potentially bring another question and challenge. They will be require more higher the PCB densities. That means the less of the PCB footprint. And in here, we would like to using the examples. The example we take would be the TE narrow MQS connectors. This is a very famous the connector platform for the automotive the engine ECUs. And for the engine ECUs, even is the traditional internal combustion engines, but you already can see there's already the market change happening for the miniatures, or we said there's a downsize on the ECU and even the connector on the ECU. So in case of you get a smaller ECU, you also can imagine that the wall thickness for the connector on the ECU will get in the thickness. And the mechanical performance, there would be the questions. To considering the miniatures leading to the thinnest wall thickness designs. So the potential risk we are indicating in here is one of the questions would be the weight line strength. By using the two different type of the base polymer, including the dsm-40 and PA60 material from competition companies, you can see the weight line in thinner wall thickness, like the 0.2 millimeter wall thickness. The weight line can easily to be found from the PA60 material. And for the PA40 materials, they are clearly indicating no weight line will be occurred. And the weight line will always be the potential risk for the crackings, especially for the automotive. You always need to proceed for the several different testing, including the mechanical shock, thermal shock, or the temperature cycling. And they will trigger in the crack in case of the weight line occurred. So to make sure without the cracking issues, you need to make sure the material have the highest weight line strength. We put in the table in here to compare with the different PPA materials. The highest weight line strength, and then you get less of a risk for the crack. Referring the photo in the right hand side, you can see the connectors with the different PPA materials after the reflow. The thermal stress released and the low weight line strength also bring in the crack. Another example, we're using the thermal shock, or we say the temperature cyclings, to explain the importance of the weight line strength. The higher weight line strength after the temperature cyclings, and including the vibration testings, you always cannot find the crack. So you can make sure your connector will be fully function in the harsh environments. Besides of the physical testing, or we say the mechanical testing, the chemical testing also is quite common to see in automotive connectors. We're using another example in here, there will be the Fakra connectors. And in Fakra connectors, the testing including using the bracket fluids. And the bracket fluids to immerse with the different materials and require the good mechanical retention after the chemical agents. With the good performance for the chemical resistance, you can expect in the material like the dsm-40 Ace, the mechanical retention can be reached at 98% after the 1 week to immerse with the bracket fluid. For the third topics, we join a little bit for the reflow connectors and using the autonomous driving market developments as the example to explain the reason why the reflow connector getting more and more, and also why the reason the reflow soldering getting more and more popular. This is the typical example for autonomous driving. It's shared by the NVIDIA, that's the leading company for the autonomous driving technologies. You can see the car computers in these PCB designs. For the connectors they're using, including the header connectors, Fakra connectors, and high-speed data connectors. To look at the roadmap and getting the highest level of the autonomous driving technologies. And then you see the difference is the amount of the reflow connectors. For example, in level 1, you only need the 1 header connector and 2 high-speed data connectors. But for much higher the autonomous driving levels, like a robotics, they require the 1 header connector and 12 HSD or Fakra connectors. So that means the more complicated the design, more advanced technology in autonomous driving require more reflow components. For the reflow soldering process, the one key topic you need to focus on will be the peak temperature during the reflow. Another similar process we call the pin-in-pass (PIP) process. They also require the high soldering temperature, similar like a reflow. The typical peak temperature in reflow will be 260. For the PIP, the typical peak temperatures will be in range start from 235 until 255. So both soldering processes, they all require the good heat resistance for the plastic. And the main challenge or the main issues you face when the reflow or the PIP is required, there will be including blistering and the webbing or even the cracking discolorations. Especially for the blistering, I think there's most essential requirements to have the better blistering resistance of the materials. To minimize the risk of the blistering, you can easily follow in the JEDEC moisture sensitivity labels ratings. The highest rating will be the JEDEC level 1, and the lowest one rating will be the JEDEC level 6. With the JEDEC level 1 ratings, that means the parts after molding and the packings in exposure without any protection of the packagings, the flow lifetime is unlimited. And the JEDEC level 2s, that means the flow lifetime will be within 1 year. And the difference for the highest the JEDEC ratings, there will be the minimize your packaging, your cost of the packaging. For example, for the JEDEC level 1 materials, you can easily to using the polypropylene plastic bag to seal in your connectors, and that's all. But in case of you have the JEDEC levels 6 materials, they will be extremely sensitive for the moisture, and then you require lots of the procedure, including the vacuum processing and the aluminum bag, and also the die scan to avoid any moisture absorptions, and that's additional cost for your system cost. So to choosing the highest JEDEC MSL ratings material also can be benefit for your total cost. We also do the studies in different base polymers compared to the DSM-40 and 60 and the other 60 material or 90 materials. And for the 60 material, especially to copolymer or blend with the PA66, the material to absorb the higher the moisture, and then there will be the risk for the JEDEC level 2s. Then you probably will see the blistering in your parts. Currently, most of the PPA was run as the JEDEC level 2s. DSM by the unit C4 technology, we already developed new base polymer for Fortii Ace, and this material can really get the ratings for the polyamide materials to achieve the JEDEC level 1s. We did several crucial testing, including to increase the reflow temperatures up to the 217s, and also considering putting the regrinding material start from 25%, even up to the 50% in our test plate, and to observe the reflow processes is ending the blistering. The outcome indicating for the dsm-40 Ace material is very robust, the JEDEC level 1 ratings. There is no risk on the blisterings in the various thicknesses. For example, start from the 0.4 mm up to the 3.2 mm, you cannot see the blistering in the Fortii Ace materials. Besides from the blistering, during the reflow or the PIP, since the exposure on the high temperatures, another topics or issues bringing in, there will be the discolorations. And based on this reason, the material with the good color stability also will be required. For dsm-40 Ace materials, we did the testings in the reflow ovens without the nitrogen protections and direct exposures on the air conditions. The discoloration can be minimized, and based on the visual inspections, it will be very difficult to find the difference between the reflow air conditions and the original, that means the before reflow. So color stability would be critical in the reflow, and you need to choose the material have the less discoloration after the reflow. To have an overview on the DSM solutions in the reflow connector or applications, in terms of the different wall thickness designs, for example, like the wall thickness below 0.8 millimeters, and you can consider in the DSM standing of 4.6 to get a benefit in the higher flow and higher crystallinities, and shorten your cycle times. Also have the good wear resistance and good toughness. And the past design with the wall thickness higher than or more than 0.8 millimeters, then DSM-40 PPA material, they will get the robust rating start from the JEDEC level 2 and up to the JEDEC level 1 by the dsm-40 Ace base polymers. DSM Engineering Plastic as the global company, we also provide you the 24/7 size powers. And we also covering the global wide, no matter in Asia, Europe, or North America. To learn more and find more information, please visit DSM's Plastic Finders for the technical information, or you can feel free to contact me via the emails addressed in here. Thank you for your listening today. This is Lennon Chu. Let me know if you have the further questions. To send me the email or contact our contact windows in the website.